In this tutorial, we are going to continue example 7 part C, where f of x is 4x squared minus 8x plus 3. In part C, we are asked to find the gradient of y equal f of x at the points where the curve meets the line y equal 4x minus 5. Let's remember first that from the previous part, we found dy by dx or f prime of x equal to 8x minus 8. Then, in order to find the gradient of y equal f of x at the intersection point with y, therefore we can imagine it as we have this function and this straight line with the equation y equal 4x minus 5. It intersects the parabola at 2 points. Then we are going to find the first step, the intersection points between the straight line and the parabola. In order to find these points, then we can write y for the parabola equal to y of the line, or y of the curve equal y of the straight line. Now we do direct substitution. 4x squared minus 8x plus 3 equal to 4x minus 5. Then now we can move 4x minus 5 to the first side and change the signs. Thus we have now 4x squared minus 8x plus 3 and plus 5. It's plus 8. 4x is going to be minus 4x, so equal to 0. This is equal to 4x squared minus 8x minus 4x is minus 12x plus 8 equal to 0. Now we can divide all of the equation by 4 because we have highest common factor, that is 4. So we can divide all of the equation by 4. Dividing all the terms by 4, so we are going to get x squared minus 3x plus 2 equal to 0. Comparing this equation with the general quadratic equation ax squared plus bx plus c equal to 0, then we can say a equal 1, b equal to minus 3, and c equal to plus 2. Now the second step is to solve the quadratic equation in order to find the values of x. Using the formula, we know that x equal minus b plus or minus the discriminant, all divided by 2a. Let's find the discriminant, that is b squared minus 4ac equal b is 3 minus 3, then minus 3 squared minus 4 multiplied by 1 multiplied by plus 2. This is equal to 9 minus 4 multiplied by 1 is minus 4 multiplied by 2 minus 8, then it's equal to 1. The square root of the discriminant is then equal to 1. We are going to substitute it once plus and once minus. Then x equal plus 3 plus 1 divided by 2 equal 4 over 2 equal 2. And now we are going to substitute the discriminant minus 1. So we get x equal plus 3 minus 1 divided by 2 equal to 2 over 2 equal to 1. Then now the intersection is going to be first at x equal to and at x equal to 1. We don't need to find the value of y at each x value because we are not asked to find the coordinates. All we need is to find the gradient. So let's now move to the third step, where we have the 2 points or the 2 x value for each intersection point, x equal to and x equal 1. We are going to substitute each value in f prime of x, that is 8x minus 8. So first we write the gradient 1 for the value x equal to or f prime of 2, and second for f prime of 1 where x equal 1. Let's do direct substitution in f prime of x. For f prime of 2, then 8 multiplied by 2 minus 8 is equal to 16 minus 8 equal to 8. And f prime of 1 equal 8 multiplied by 1 minus 8, then it's equal to 8 minus 8 equal to 0. Then for x equal 1, f prime of 1 equal to 0. Therefore, we say at x equal 2, the gradient of f of x equal to 8. And for x, or at x equal 1, the gradient of f of x equal to 0. So now we solve part C. We found the gradient at each intersection point. All the steps that we did are very important to practice them, so we can move to exercise 7C and try to solve exercise number 2, where we are asked to find the gradient of the curve with the following equations. And then we can move to part 3 or exercise 3 as well.